And welcome back, and it is the 27th of April, further maths 5 a day, and let's just go straight to the first one. Right, what do we have? The first thing I would notice is we have pluses and minuses here, so therefore we can only add and subtract surds if we have the situation whereby it is the same surd, in other words the same number inside the square root or the radical, whatever you may want to call it. So I need to think a way of simplifying all these things, and I'm going to start by looking at this one here, because I know that 8 is 2 root 2. And again, let's sort of break it down. So I know root 8 is the same as root 4 times root 2. The square root of 4 is 2, so therefore I know this is 2 root 2. If I have 4 lots of 2 root 2, I have 4 times 2, which is 8. So therefore this one here is 8 root 2. Let's just zoom in a little bit down here. Now that's crucial because now I know the significant thing I'm looking for is root 2's, which is what I'm adding together. So now I've got that in mind, I can think about the square root of 98. Now, even though I may not know it straight off the top of my head, it is the case that 98 is the same as 49 times 2. I know the square root of 49 is 7, so therefore I can say that this one here is the same as 7 root 2. I'm just going to get rid of these arrows so they don't become confusing. And then similarly with 242, well that is definitely a bit more tricky, isn't it? So 242, let's divide by 2, let's just do a prime factor tree, which is going to give me 121. And actually I feel a bit better now because I know that is 11 squared. So therefore I can say this one here is the same as 11 root 2. So I've got 11 root 2 minus 7 root 2, add back 8 root 2, altogether that's going to give me 12 root 2. Again, point of this question, I can only add or subtract surds when it's the same surd that I'm adding or subtracting. Next question. A circle has equation, gives me a circle with an equation. Now I'm just going to write down the thing I always do, even if I don't really need it. So C is minus 8, 4, and the radius is 5. It just stops me making a silly error by jumping in. And then it says, is the point minus 5, 3 inside or outside the circle? Well, the way I'm going to do this is I'm going to work out the distance from the centre, so the centre you'll remember is minus 8, 4, to this point here. So it's just Pythagoras. So the change in the x values is 3, minus 8 to minus 5. The change in the y values is 1, so that's going to be 1 squared. Pythagoras means I square and add these things together. 3 squared is 9, 1 squared is 1. Add them together is the square root of 10. Now, even on a non-calculator paper, the square root of 10 is clearly less than 5, because it's somewhere between 9 and 16, so it's between 3 and 4 when I do the square root. So therefore I'm going to make a clear statement that's less than 5, which implies, now if it's less than 5, it must be less than the radius, which means it must be inside the circle. And that is question done. Again, do note on this, clear conclusion. Don't just write down an inequality without stating why you've written the inequality. Next question. Solve the simultaneous equations. Okay, we haven't done one of these in a while, have we? So let's just go for it. So what do we have? So we've got an x and y, 2z. It's not anything that immediately looks obvious. Here's a quick way of doing it. So I'm just going to do the usual. Let's label them 1, 2, and 3. I would notice that 1 and 2 eliminate my z's, so that's probably where I'm going to start. So let's just do 1 plus 3. And then I've got x plus 5x, which is 6x. Y plus 4y, which is going to give me 5y, and 2z minus 2z goes away, which leaves me with 40. And I'm going to call that equation A, just because I'm then dealing with the two-factor equations, or the two-term equations, if you like. Next one. So I now need to combine two other equations in order to get rid of z again. So let's just do the easy one. Let's just do equation 3, or let's do 3 times equation 1, I should say, and let's just do 2 times equation 2. Okay, so 3 times equation 1 is going to give me 3x plus 3y plus 6z is equal to 4, not 40, because I'm doing it by 3, is equal to 3 times 40 is 120. And then 2 times 2, which is going to give me 4x minus 2y plus 6z is equal to, multiplying that by 2, so that's equal to 10. Now, because they're both plus 6z, I'm going to take these away. So 4x minus 3x is x, minus 2y minus 3y is minus 5y, 6z cancels with a 6z, and 10 minus 120 is minus 110. That's not necessarily the nicest of functions, but that's fine, that will do. The point is, a and b are both now in terms of x and y only. So I can think about what to do here. Well, let's take, where shall I do it? Let's do it over here, so I've got a bit more space. So let's just write down equation A again. So equation A is 6 plus 5y is equal to 40. That's my equation A. And I'm going to take equation B And what shall I do? Let's make the x's the same. So I'm going to multiply this by 6, which is going to give me 6x. Remember, I'm multiplying b by 6, minus 30y is equal to 6 times 110. Well, these are going to be quite big numbers, aren't they? Which is going to be minus 660. And again, I'm going to take these away. Now, which way round should I do it? Let's do the top minus the bottom. So 5 minus minus 30 is 35y. And 40 minus minus 660 is 700. So actually, because I know 35 is half of 70, I feel a bit better now because it feels like this number might be a sensible number. Divide both sides by 35. Well, 70 divided by 35 is 2, so 700 divided by 35 is 20. It's not a great number, but it's a whole number, so I feel like I've probably done the right thing. Let's put this back into equation b. So equation b I can rewrite as x is equal to minus 110 plus 5y, which is the same as minus 110 plus 5 times 20 is 100, which is going to be minus 10. So I've got my x, I've got my y. Let's pull them all together into equation 1. So equation 1, so x, you'll remember, is minus 10. My y is 20, so I'm adding 20. So I'm putting it into this equation here. Plus 2z that I don't know is equal to 40. Minus 10 plus 20 is 10. 2z equals 40, which means that z is equal to 40 minus 10, which is 30, divided by 2, which is going to give me 15. And let's write it all out nicely at the end. So therefore x is minus 10, y is equal to 20, and z is equal to 15. And that is that question done. Not too bad, actually. I was going to say question's done, but I just realised there is one below, isn't there? So final question today. Show that for all values of f of x is decreasing. Now you'll remember decreasing actually specifically means that you need to show that you understand that the derivative, or first derivative, is less than 0. So let's work out what the first derivative is. So the first derivative is going to be, bring down the power, which is 12x, take away 1 from the power, minus 30. And actually we've got a sneaky cube at the end, haven't we? So minus 6x squared at the end. Now I need a way of clearly showing that all these values are less than 0. So what I'm going to do is I'm going to complete the square. So it's going to be minus 6 times x squared minus 2x minus 30, which is going to be minus 6 times x minus 1 squared minus 1 minus 30, which is going to be, now be careful here because it's minus 6x minus 1 squared. Minus 6 times minus 1 is plus 6, so that's going to give me minus 24. And then I need to make a clear statement that I understand that this is less than 0 for all x. Upside down, a just means for all. And so therefore, conclusion, it is the case that f dash of x is less than 0 for all values of x, which implies decreasing. You don't need to say a lot more than that because you've demonstrated you understand what's happening and you know what's going on. And that is it today done. Again, as ever, good mix of questions today. Really like that third question at the start, very much a non-calculator question. And actually, I didn't really touch my calculator at all today, did I? I could do all without a calculator, so should you really. Make sure you're sort of doing as much as you can without that. Either way, like, subscribe. See you tomorrow. Thanks all.